So these are the four the data types we just talked about. And so we mentioned that for different data type, there's an associate with the operations, and so many of the operation applies for all the different types. And also we talk about arithmetic operations. Okay, so most of these are plus, minus, multiplication, division, and modular operation. This is probably a kind of strange for some people, but modular is pretty much the same as the division for the integer types, but the modular operation gave you the remainder. So I think addition, subtraction, multiplication, there's no issue with that. But for division, you must be careful, because depend on what is the operand. So if you try to divide a two integer, and now in math, you don't have that issue, because if you say 5 divided by 2, and then you will say, oh, 5 divided by 2 is 2.5. Okay, so that's the answer. But in computer language like Java, they can actually check what is the type for A and what is the type for B. And then find out, okay, A is an integer type, B is also integer type, and then the division, the result should be also an integer. That's basically how most of the language is designed. Okay, so in that case, 5 divided by 2, 5 is an integer, 2 is an integer, and 5 divided by 2 is a 2.5, which is a floating point number. Okay, that's not right. So in Java, they try to correct it. So the result should be integer as well. So 2.5, so I have to convert the 2.5 from floating point to integer. So that's why in Java, 5 divided by 2 will give you 2, not 2.5, because it will check to make sure the result has the same data type as the operands. Okay, that's basically what they do. Now, so this is a kind of interesting, because sometimes it's going to actually cause an error, because if you did not pay attention to the type, you hope that the 5.2 you'll get 2.5, but that's not the case. It's actually give you 2. But sometimes people actually intentionally take advantage of this this property. So just say, okay, I want to actually get the integer result. So that's what I want. So this is good. But just keep in mind that this is how the Java is defined. Okay. Now the other operations also, the modular operations also for the integer. Now when you talk about A modulo B, so Java going to do the division as well. However, the result is not the quotient. The result is the remainder. Okay. The result is the remainder. So this is actually interesting. So if you want to actually do the division and you want to get a correct answer, the accurate answer, you make sure that both A and B are floating point, and then you got the correct result. So if you actually say, I want to divide it by 5 by 2, I want to get 2.5, don't do 5 and 2. You do 5.0 and 2.0, and this is going to give you this. Okay. You have to put the, make both the operands the floating point as well. So as for the integer type, these two operation gonna give you some kind of interesting result, because so when you divide 5 by 2, so you're gonna say, okay, here's a 2. That's the 2 times 2 is 4, 1. So that's the quotient. That's the remainder, right? Okay. So 5 and 2. So basically 5 divided by 2, this gave you the quotient, which is 2. And 5 modulo 2, this gave you the remainder, which is 1. Okay. So this gave you the quotient. This gave you the remainder. If you actually deal with integer numbers, and these two eventually give you this result, which is pretty good, right? If you actually realize this is what Java going to do. Okay, now let's get back to the chapter 2. 2.13. If you look at the Zybook, 2.13 is the binary. Now, we're not going to spend much time on binary, but you should at least have some knowledge of binary. The reason for this is because even though when you write the Java program, we don't directly deal with binary, but just keep that in mind. Every character, every number, everything you just typed in Java, it will eventually convert to a binary digitals before the computer can execute. Remember that one. So this is how you can interpret. When we deal with number, we deal with decimal number, but the computer only deal with binary. So the binary is a language that the computer use, and we use the language of decimal or character or other things. So now, some of the basic knowledge you need to have is you need to know how to convert between binary and the decimal. Have you actually learned anything about the binary?
No.
No? Okay.
Binary was covered in computer science 1 last semester.
Yes, it's covered. It's supposed to be covered. But you should realize, in Zybook, you can actually, here's the 2.13, the binary. So please read that particular section. It can basically give you some kind of idea how can you convert between binary and decimal. Now, things that the difference between binary and decimal is not really that big, even though it looks like a very different numeric system. The reason for this is because for decimal, you basically use actually 10 symbols for decimal. 0, 1, 2, 3, 4, all the way to 9. So from 0 to 9, you use 10 different symbols. And for binary, you only use 2 symbols, 0 and 1. Okay, for 10 symbols, when you count all the way from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then you want to add additional number, then you have to reuse these 10 symbols. So the way you can do this in the numeric system is you basically reset the value to 0, and then you're going to carry number 1 to the next position. It's called the 10th position. Okay, that's basically what the binary can do. So when you count the number, so it is 0. Sorry. So when you count the number, it's a 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And if you want to add another one, then you're going to actually put the 1 in the next position. Okay, and reset to 0. So that means this position is called the 10th position. And this is called the 1st position. So every number over here in 10th position should be 10 times bigger than the corresponding number in the 1st position. Okay, so if you continue to count, then that's 11, that's 10 plus 1, that's 11. And if you continue to count to 19, then next number going to be, you have to reset to 0 and carry 1 to the next position. And now there's another 1 in the next position, 10th position. So now you have 2 actually 1s in the 10th position. So you got a 2. So that's how you count the binary decimal number. But the binary is 0 and 1. So once you got a 1, then you cannot use 2 because only 2 symbols are allowed. So all you need to reuse the number, so you can set this 1 to 0 and carry 1 to next position, because you're going to carry to the next position for every 2 counts instead of 10 counts. So that's why this is called a 2th position. And this is a 1th position. Okay. Now, because of this, so so I like this tool in the Xi book. So this is going to give you some kind of idea how to do the conversion. For example, so this is actually 8 bits. 0, 1, 2, 3, 4, 8 bits. Each bit can actually either put 1 or 0. So this is called the 1st position. You can see the 1 here. And this is 2's position. And then the next one doubles this is the 4th position. And next one doubles the 4. Next one doubles the 8. So it's always doubled. So for example, if you want to actually make, just convert between a decimal and the binary. So here's the 1. So 1, if you put the 1 and the 0, 0, 0, 0, 0, 0, 0, 1, that's corresponding to decimal value 1. Now, if you put the 1 here, that's decimal value 2. And that decimal value 2 plus decimal value 1, that's 3, because 2 plus 1, that's 3. And that's 3. And decimal value, that's decimal value 4, right? That's 4, because that's, so plus the 3, that's 7. So plus the 1, that's 5. So you can actually just do the conversion between binary and the decimal we're using this tool. It's pretty cool. But and all I want to say is that every value, like a 253, when you say 253, but when you store it in the computer system, in the computer memory only store these binary digitals. That's actually what's stored in the computer memory. Okay, not this one. Okay, so that's why we need to know a little bit about the binary, but I'm not going to spend much time on binary, because other than how the binary is going to be used in computer, we are not going to talk about the binary in this programming course. Okay, so please spend your time on 2.13 section and practice with this. Now, the computer character, the character actually is another type in Java. So you can use that to declare a character, like a char space my car semicolon. That's how you can declare my car as a character. So then you can just put my car equals B. So that means my car represent character B. Okay. Java can also import the character using the scanner, but in the syntax is like this. Now, don't ask me why we use car at 0, because that's basically the syntax. We're going to talk about it in detail, because Java is using the actually scanner. It's easy to import the character string, but the character it's just a very kind of special string because it contains only one character in that string. But it's not the same as string because when you actually see string use double quote, but a character use single quote. So that's a difference. So character basically represent each individual character. Okay, string basically is it's a sequence of character. That's the difference. Okay. Now, also you need to realize is the escape sequences. That's also discussed in Python. So for certain of the characters, it's very difficult to use any symbol on the keyboard. So for example, the new line. So normally we use the you know backslash n. Backslash is the escape character. So that's the escape sequence. So you use two character. Backslash n represent a new line. Now, if you want to actually represent a tab, then you can put the backslash t. This is very important when you try to print a sequence, a string, because when you print a string, then you want to actually, you know, just add a tab between two words. Then you can put the backslash t, and then you can type one word backslash t another word, and then in the print out the statement, you can actually generate a tab in there. So single quote, you cannot directly use a single quote. You need to backslash single quote, double quote. Okay, and if you want to really put a string, a backslash in a string, you cannot directly put the backslash because this is going to confuse people. Okay, so you have to use the backslash twice. That means just one backslash. For one backslash, you need because the backslash itself is, you know, the escape character. So now when you see one backslash, you try to, you know, represent the symbol backslash, but the computer can interpret this as escape sequence, escape character. So that's why you need to put it twice. Then this will be counted as just one backslash. Okay. Okay, so we're gonna practice more. The way you can understand this is by doing the practices. Now, let's spend a little bit more time talking about the strings. Okay, string, you can declare string just like an integer, right? String, I can say my string. Okay, so I declare my string as a string type. However, there's one difference between string and the integer. If you declare, so if you declare a as an integer, then you can say 20, a equals 20. So that means you assign 20 to a, right? So that basically means in the computer memory, when you declare a string, a character, declare integer a, then you basically reserve a space in computer memory. That space is actually 32 bits. Okay. So when you assign a equals 20, you basically actually put 20 in there, right? That's assignment. So that means the memory space reserved for a gets a value 20. So basically assignment basically means assign 20. You put 20 into the space that reserved for a. Now for the string, you can also reserve a space. Okay, that space is reserved for string. And then you also reserve a space for my string. Now that space also is a fixed size. Okay, it's a fixed size. Now this is going to cause some problem. Okay, now why? Because if you say I assign declare x as a string, and then I'm going to say x equals my friend. Okay. So here's a string, my friend. I assign this string to X. Okay. And then how much space this string gonna take? If I actually assign a long string, say I have a string like my say this is a computer science class. Computer science class. It's a long string. Okay. Now, how can I guarantee if you so how can I deal with that kind of issue? Okay, because the string could be very long, could be very short. Okay, now if you reserve a fixed size space, how can you store that string? Because you never know how big the string. Maybe the string is too long, so you cannot fit into that space you reserve. So how big is the space you're going to reserve? Okay, now in Java, that space is fixed, and it's not very big. Now what the Java going to do is, the Java going to actually, when you actually do the assignment, say my friend assigned to X. So basically Java going to actually create a space and store my friend. Store the string in the memory location. Now, if I say my string equals this is a computer science class, and then Java gonna actually reserve another space, says this is a computer class. Okay, it's too long, so I cannot put the whole words in there. So I just use . Okay, so definitely this string gonna require more space than my friend, right? So in that case, when Java do the assignment, Java never gonna actually copy my friend into X. So when you say X equals my friend, what the Java gonna do is Java basically point X to that object, which basically represent my friend. Okay, what does the pointer means? Basically, now whatever this string is stored in a computer memory, and Java can actually just put the memory address of this object into the space that reserved for X. So that means it's only stored address, memory address. It stored the memory address of this real string. So the real string is actually stored somewhere, and then Java just actually put the memory address of this object into the location. So it's actually just like you actually point X to the object. So you point X to the object, which actually stored my friend. So when you do my string equals this is a string, so this is actually point my string to this object. So that's the assignment. You see the difference between the string assignment and the integer assignment. Integer assignment, when you assign 20 to A, you actually put the 20 into the space reserved for A. When you assign string, you don't actually copy the string value into the space. Okay, you just point X to the location. And this basically only stores the memory address. So that means X and the my string defined as string type, it just reserves the space enough to hold one memory address. Now, typically the memory address is like 32 bits. Okay, it's the same size. That's called a reference. Okay, so that's why A string variable is a reference type. So the type variable that refers to a string object. An object consists of some internal data items plus operations that can be performed on that data. So when you say string movie title equals Frozen, then declare a string reference variable named the movie title that refers to the, in that case, the movie title is a string type. Now, Frozen is a string object. So when you actually do this assignment, you basically point movie title to the Frozen, or to the object called Frozen. Okay. Now, what about if I say integer, yeah, if I declare another integer b, and then when I say b equals a, what does that mean? So when I declare another integer b, that means Java going to reserve b, right, as an integer, 32 bits. When b equals a, so that means I'm going to assign the value a to b. So what's the value of a? It's 20, right? So when I say b equals a, so basically I'm going to copy the value stored in a to b. So b got 20. Now what about this? If I do the assignment for my string equals x. So here's a string, here's a string. So I assign the string x to another string called my string. So looks like my string gonna contains the same value as x, right? So x is actually pointed to my friends. Now my string is currently pointed to, this is a computer science class. That's my strings pointed to. But after this assignment, what are you gonna see? What are you gonna expect to see? So my string gonna contains the same. My string also gonna be, hopefully my string gonna also gonna be my friend, right? Because once you my string equals x, x is my friend, so my string should be my friend. Now what does the operation do? Again, this is gonna actually reroute this my string from the current object to here. So that means this assignment, my string equals x, basically perform this. So the my string gonna point to the same object that x points to. My string gonna point to the same object that x points to. So x is pointed to the object, the string, my friend. Currently, my string pointed to the string. This is a computer science, basically. But after actually my string equals x, so my string gonna point to the same object that x points to. Remember that. That's called the reference. Okay. So the reference basically does not change the value of this particular one. It's just repoint this value to a different object. Okay. So
Professor, I have a question.
Yes.
What happens to the object once nothing is pointing to it? How does it get deleted to save space?
That's a very good question. So like in this case, right? Like in this case, once you say my string equals x, so then you're going to cut my string. My string is no longer pointed to this and pointed to something else, right? So now you're going to have a situation that this particular object, this particular string is nothing you have nothing pointed to this object, right? Okay. Now, this is called a dangling object. This is really bad. I did not mention that one, but I'm glad that you asked that question. But in that case, initially my string was pointing to this is a computer title pointing to that object, but suddenly you just say the assignment basically, assign my string my string equals x, so that means my string gonna point to the object that the x point to. It's not no longer point to that one, so you just reroute the pointer to that one. So this is gonna leave this object, so this object that we're gonna be handing here, no string type is pointing to. This is bad. This is called actually dangling object, and this eventually going to cause some leaking memory leaking, because you have something over here and no one is pointing to it, and no one knows how to point to that one because that object has a memory location. But for this object, there's a memory location, but I know what is the memory location because the memory location is stored in here. And also, once you have an assignment, this memory address is going to actually store over here. So here and here, X and the my string basically contains the same memory address of this object. But this one has nothing to point to. That's called actually a dangling object. This is really not good, So in most of the language, like a C language, if you have anything like this happening, this is going to cause some loss of memory space. So if you have a too many dangling object, this is going to cause something called memory leaking. So that means the memory space can be used to become smaller and smaller and smaller because a lot of space has been used by some kind of object like this. It's not being used, but it takes some memory. Okay, so that's called memory leaking. Now, in Java has some special approach. Java has some kind of mechanism. It's called a memory garbage collector. So Java going to periodically check any actually dangling object, so that the object is declared, but no one is actually using it. So in this case, Java they're gonna collect these objects and delete them. It's called a garbage collector. But that's basically one of the features Java has. But yes, it is a very bad situation. Any questions? Okay. So like this case, so then if I declare another actual variable called a favorite movie. So favorite movie is also a string. Okay. So if I say favorite movie and assign to movie title, so that means you're not going to copy the actual movie title, which is a string, to the movie title. Actually, you're going to reroute the movie title and assign the favorite movie's reference to the movie title. So the movie title eventually gonna point to the same movie that the favorite movie is pointing to. So that's basically the reference. So you just need to realize this. And I'm not going to talk of any more at this moment. But once we actually use eventually use many examples, applications, you would realize that the reference type is very different from a traditional type, like a data, like a integer or floating type. And these type are called primitive type. So every time when you do the assignment, you basically copy the data into the place. But the reference type, basically, when you do the assignment, you basically just point one of the string type into the other object. So you just reroute the pointer. Okay. Now you can also use the scanner to import the string. Okay. Now if you actually use a scanner, if you type a string like a hello space there, and you can use a scanner next function method. Okay. However, the next method only actually import one word. If the next method see a space, then it will just cut it. Just so, for example, like a hello there, so you need actually two, scanner statement. You need to call next twice because the first next only import hello, the second next import there. Okay. Now, if you want to actually, type hello space there, and if you want to actually assign hello space there, the whole string into one string actually type variable, then you need to actually use another method called next line. So that means that you can actually put the whole line of string into one string variable. Okay, so that's a difference. You can check the difference between these two. Okay. Now the next thing we're going to talk about is it's called integer overflow, and remember that when you declare a type as an integer, actually the Java going to reserve 32 bits memory space. Okay, it's a 32 bits. That means if you want to assign an integer to it, if you assign 125, that's fine. That's not a problem. But if you want to assign an extremely big number, the number is so big that the 32 bits cannot accommodate that number, that's called overflow. Okay. Now, in that case, you can change the type. Instead of using integer, you can use another variable type called long. Okay. So if you use long, so this is going to actually reserve 64 bits. Okay. So this is going to give you a larger, actually much bigger space. Because think about this. If your actually space is doubled, for example, if you can actually accommodate the 3 digitals, then the largest in decimal, the largest number you can accommodate is 999, right? If you can accommodate not 3, double the number, 6 digitals, you can actually accommodate, right? 6 digital can accommodate 999,999. Okay, that's much bigger than 999. Okay, so that's basically why the long gonna actually accommodate more numbers, but still it's limited. Honestly, if you try to actually define any type in computer, because the computer resource is limited, the computer resource is limited. So there's no way, there's always a number that's big enough, that even bigger than the type the long can accommodate. 64 bits can accommodate. So here actually we define these. So here's the actually what are different type of integers. Now, if you actually try to declare some of the integer, but you don't think that the integer can be bigger enough, relatively small integer, you can use a type called a byte. So you can say byte x. So that means X can, the memory actually, Java can reserve actually 8 bits memory space. Now, what's the number you can accommodate for 8 bits? The 8 bits can actually accommodate from negative 128 to 127. Okay. If you actually try to accommodate the 8, actually the largest number 8 bits can accommodate is 255. But if you actually count the sign, the positive and negative sign, then you have to actually reserve one of the sign to one of a bit for the negative and the positive sign. Then you only have 7 bits. Okay. And another type is called short. Short can actually reserve 16 bits. Now int can reserve, that's widely very popular actually integer type. It's called int. It reserves 32 bits. And the 32 bits can accommodate number between here and here. So that's the largest number you can accommodate. Long, 64 bits, that's this. That's a huge number. Okay. I think it can handle most of the application. But if you want a number which is larger than this number, then you got to overflow. Okay. Same thing for the floating point. You have float and you have double. Float use 32, double use 64 bits. Okay, so that's basically. Now which type are you going to use? Because you have a byte, you have a short, you have an int, you have a long. Now, which type you should use? And most people say, well, I'm going to use long because if you can actually store the number in byte, of course you can store the number in long, right? But not the other way around. So I can store the number in long. Now, what's the drawback if you actually always declare a number type as a long? Because for long, the computer actually, the Java can reserve 64 bits. If you have use a many actual type which is long, then you're going to use a lot of memory space. Okay. Now for some of the application, you just need a small numbers. Okay. You just need a small numbers. For example, if you want to say, I want to define a class size as some sort of integer type. Now, what is the type you can recommend? Now, in computer science department, most of our class size is actually around 20, right? Because our class size is limited mostly by the lab size. So if the lab size is actually, you only have actually 20 computer labs, then you cannot have more than 20 students in a class. So in that case, we can reasonably define using byte to define our class size. Because then the class size only takes 8 bits. Okay. Not going to save a lot of space. But if you have a bigger class size, so your class, you can take the class in a large studio, and the instructor actually sitting in the center and just talk to the big audience. Now in this case, if you have 300 students, then byte is not enough. Okay, so then you can think about a short. Short is actually, I'm pretty sure short is enough, right? 32,000, That's a big audience. You can use short, 16 bits. Okay. Of course, you can use int, but why you want to use int? Because you can do the same thing with a smaller memory size. Okay. Any questions so far? Now, also Java defines a class called a random. So it allows people to generate a random number. Okay. Now, random number is actually is by its definition, the random means it's not predictable, right? So now in computer language, the random number generator is very important, because if you want to design a computer game, and in many of the computer game, you need to actually have some kind of random number generator, because for example, if you want to do the gambling, if you say, okay, I have a bag, the bag contains four balls, okay, and each of a ball I put a number in there. One is 0, the other one is 1, the other one is 2, the other one is 3. So I have 4 balls. Each has a different, each has a number in there. So I can just randomly pick a number in the ball, and it could be 1, could be 2, could be 0, could be 3, right? So that's a random number, okay? Now computer, you want to write the computer program to simulate that kind of things. Random generator is a very, very good class you can use. Okay. So I'm not going to actually talk about the syntax of this, because it's very straightforward. You just need to define a random class, right? You can just define a random class and generate a random number. So then you can use the random, like a next int. This is going to get actually, so every time you call next int, you're going to actually import a number, which is kind of a random. Okay. So this time you import the number 3, and the next time you import the number 4, and next time you import number 20. You never know. Okay. That's a random number. Okay. Now, if you want to actually make sure that you have a certain range, so you want to generate a random number within certain range. For example, the random number going to be among these, 10 digitals, 0, 1, 2, 3, 4, all the way to 9, then you can use next int. Okay. So I want you to read actually 2.18 and perform the exercises over there. Okay. So so the random number, as I say, it's kind of important. Now, the truth is, in Java or many of the computer language, the random number they generate are not really a random number. Okay. It's just to give you a feeling it's a random number. It's actually a pseudo-random number. Okay. So it's actually a pseudo-random number. It's not really a random number. So because computer use some kind of formula to generate a sequence of number, looks like a random number, but it's actually not. So it has a certain kind of pattern. But because it can fool people, give people a feeling that it is a random number. So that's why it's called a pseudo-random number. Okay. Now the random class provide a various different way for you. So if you want to randomly generate a number, so the random number generated requires some kind of something called a seed. You can provide a number, then you're going to generate a number. Provide another number, you're going to generate another sequence of random numbers. The reason for this is because sometimes you want to create a software to generate a random number like a computer, the gambling, but you want to actually test it. So you want to actually, it looks like a random, but not completely random. You want to reproduce that sequence of random number. So then you can use the pseudo-random number random number. So please read at 2.18 for the random number. Okay, so I'm not going to spend the time over here to talk about this. The last one I want to talk about is Java API documentation. Uh, so the thing is that no matter how much time we have in the semester, really I cannot cover all the materials for the Java. So all I want to do is I try to cover some of the key topics. So that's basically why I sometimes for some of the sections I feel like this section, that material is so easy. It's not really that challenging. So I just sometimes I can skip that section. So I want you to read the section and perform the, do the exercises for the section. Now, if you do have a question, then you can ask. And that's why I want to create a group, 3 different groups. I want you to have a group meeting. So today I'm going to assign you the next group meeting. Okay, after the class, I want to actually discuss enough topic. I gave you the assignment for this. Okay, now I try to cover some of the challenging topics, or I want to cover more examples. I gave you more exercises, and also I want to do more exercises in the class. So in module 1, module 1 covers chapter 1, 2, 3, and 4. And I'm not gonna, I try to quickly go over the module 1 because most of the topics in module 1 are very similar to the the similar topic in Python in CS1. So I want to actually quickly skip that part. So, but then starting from module 2 and 3 and 4, then um, I want to actually each of the group I just actually scheduled and to discuss any of the topics and post your questions in the discussion forum on the Blackboard. I want you to do that. So sometimes I give you assignment. This is a part of the participant. I want you to be engaged. Not just me talking all the time. So that's why I want to have a group. And so uh, today I'm gonna leave like about 10 minutes and I give you some time to discuss. Okay, but so I cannot cover everything for the whole semester. So that's why you need to know how to look for help. One of the reference site is the Java API documentation. Okay, now if you actually go to let me see. Okay, so if you want to search for any topic in Java, you can just type Java. For example, I want to search for Java math. So most likely the first couple of selection gonna give you the right link. So this is actually the website created by Oracle, which is actually the owner of this Java language and the Java development environment. In the Oracle documentation, API documentation, you can see a lot of good reference. If you actually type math, it's going to provide you the class math. Okay, so the class math is going to give you some kind of overview and then all the different methods used in math. For example, ABS. I hope you still remember ABS, right? We talk about the absolute value. The other method we talk about is SQRT. That's a square root. Let's check the square root. Yeah, that's square root. Okay, so it's actually statical double. So this is actually return value, also a square root. It's also double. And also POW, that's the other type. Okay. So these are all the different methods defined in the class called math. Okay. So, and if you want to search for other topics, okay, so you can actually search for something else. Okay. So, for example, if you want to search for okay, it's a class random. So that's something we just talked about before, right? So you can read the Zai book to get some basic information about random. But if you really want to completely learn what the features that the class random provides, then you can just search the Java API documentation. Okay, so the Java API documentation provide a various different methods. So for the random class, okay. So we actually, you know, so you can actually always use the tool, online tool, to search for the Java document. Okay. So it contains the class overview, constructor summary, method summary, and the constructor and the method details. So, so as we actually move forward to next chapters, when we talk about the classes, when we talk about, then the best way to learn all the features, methods that this particular class provides, go to the Java API documentation. That's all I want to say. So in the class, we can actually provide examples, and we can talk about some very popular features for the method, but we cannot cover everything, But if you want to, so you have to know how to search and reference the documents. Okay. Okay. So that's pretty much all for the chapter 2, and I'm going to start a little bit about chapter 3, and then so I'm gonna stop. Okay. So I think for chapter 3 and chapter 4, and which is actually included in the presentation material I just posted. Chapter 3 is actually covered in module 1C. So module 1 consists of 4 parts, A, B, and C. 1C is about the branch. Okay. So again, I try to make it very quick, because branches is actually also talked about in Python. It's basically the if statement, if else statement, and also the next actually topic, module 1D, is about the loops. So and the branches and the loops are basically called control structures. Branches and the loops are called control structures. So I want to actually make it quick, so we can quickly finish the modules 1C and 1D. So the branch is basically it's if statement or if else statement. Okay. So an if statement basically executes a group of statements. If an expression is true, then it will be execute the group of statements. If expression is false, not true, then it skip the if statement. Okay. Now the only thing I want to talk about is the difference between the if statement in Java and the if statement in Python. In Java, if you define the if statement, and then here is an expression, the expression has a value. For example, I'm going to say x plus 10 is greater than or equal to 1. That's an expression. Okay. Now, if this is true, so for example, if the value of x is 1, So that means 1 plus 10, that's 11. 11 is greater than or equal to 1. So that means I'm going to execute the block between these two braces. Okay, a pair of braces. So if x is greater than, then let's say y equals x plus 1, z equals x minus 1. So then I'm going to execute this. If this is not true, then I'm going to skip that block. Okay. Now, in Python, we can do the same thing. But in that case, in Python, we have, say, x plus 10. You can also put the parentheses, colon. And then in the Python, you're going to have a same expression. You're going to have a same expression. Now, the difference is Python does not need braces. The Python's way of blocking things is use the indentation. Okay, as far as these two statements are indented after the if statement, and these are part of the block. And if I have another statement, I'm going to say A equals B plus C. So that's not part of the if statement. No matter what happens in here, this statement is always going to be executed, right? But in Python, you can write this, A equals B plus C. Okay, so Python, that's Python's way of indentation. So in Python, the format is so important. In Java, even though format is also very good, because the indentation is also preferred or recommended, because it can make it easier for people to read the code. But in Python, indentation is extremely required. It's part of the syntax, but not here in Java. Java is just make the code looks better. Okay. Now, if I actually do this, for example, if I do this, okay, if I actually delete that one, okay, and I write this. Okay. Now I don't actually indent this. Okay. It's still actually going to perform the job. It still do the same thing, but without indentation. But not Python. You cannot put the Python say y equals something, just line up with if. This is wrong. Okay. This is right. This is still okay. But as I say, to actually make the code looks nice, it's always recommended that you use the indentation in the block. Okay. Java also support the nested if statement. Okay. So if the user choice equals, here's double 2 equals, so equals 1, then you're going to execute the statement inside. Execute the statement between the brace. Okay. So the user choice is 1. Now, if this is not true, then you're going to skip that part and jump to else and check the another condition. If the user choice is 2, then you're going to actually execute everything between these braces. If this is not true, go to the else. Okay. If this is true, then go to here and then execute the next if statement. That's the nested if statement. So then if the user choice is 2, then you check the number items. If it's less than 0, execute this. If this is not true, execute this. So this is actually basically Java's way of doing the branch. Okay. So in that particular case, if you actually go into that block, that means the user choice is 2 and number item is less than 0. And that's the user choice is 2, number item is greater than or equal to 0. Okay. So then you get into here and you get into here. Okay. Now, in the expression in the if statement, normally we use the double equal to represent equality. Okay. Remember that even in Java or even in Python, we talk about, the equal A equals B in computer language. It's not say A. It's assignment. Okay. It's not the equality. Now, if you really want to compare A and B, use A compare to B. If it means that the A is equal to B. Okay. Now, if A is 3, then X is 3, then X equals 3 is true. X equals 4 is false because X is 3. 3 is not equal to 4. This represent not equal. Okay. In math, we normally use this, right? If X is not the same as 3, then we use this. But in Java, we use factorial equal. Okay, that's pretty straightforward. And there are certain other relational operators, less than or greater than, and less than or equal to B, and greater than or equal to B. Okay, so this is the relational operators. Okay, now the common mistake could be sometimes less than or equal to, use this. You never use this. Okay, this is wrong. Greater than or equal to, you never use this. Okay, only these two. Okay, I think I'm gonna stop right here, and I'm gonna, ask you to, have small group meeting. I think the next assignment I'm gonna post, I haven't posted yet. I want you to look at the chapter 4. Chapter 4 is about the loops. Now each team gonna meet, and first you can actually check the topics in chapter 4. If you have read it, that's good. If you haven't, that's okay. So you can, each individual just read each of the read the chapter 4, and then you can bring up all your questions together, and then each team gonna come up with some questions. I prefer like 3 questions. So then I hope you're gonna bring the question in next class, on the class on Friday. Okay, so that's the first actually thing. It's kind of exercise. It's a group exercises. I'm gonna post on the Blackboard so you can check the Blackboard. But I want you to start just right after, after I finish my talking, and you can continue, or you can schedule some other time with your group members. Okay, to discuss it. And I hope that once you discuss it, then you can actually post the questions each team may have on the Blackboard in the discussion forum. Okay, now, so before we do this, let me. So also a very small notice. I think I sent the group 2 email. So I think one of the student want to join, like a Stephen Day. He wants to join group 2, so I just assigned Stephen to group 2. So I just want to realize this. That's the only update I have. And so let's see. You can. Let me see what I have. Okay. Let me do. Let me actually log into my Blackboard. So you can check each group can check which link you need to log into. And let's see. So you can always check the my announcement. I have 3 links. So I'm gonna make a change for the group members. And so this is the one. That's for group 1. So I want you to do this, and group 2 and group 3. So I think I'm pretty much done today, but then I want you to actually discuss each of this, and so if there's no enough time for today, I think the class is almost done. But I hope you can schedule another time before Friday, and then discuss chapter 4 to see whether you have any problems, any issues, and you can bring that problem and issue to the class. And I hope I will make this as pretty much for every week. I want you to do that. I make it just like a norm for this class. This is just a part of uh, the class, because I want everyone to be involved in the class, that you can read, and then you can actually bring some questions, and then we can discuss. And typically, I want to ignore, I want to skip some of the topics I think it's not really that challenge. So you can read the iBooks and do the exercises, and we will let it go. But for some of the chapters, some of the sections, it will be very challenging. I want to spend more times in there. So, okay, so that's pretty much all I want to do. Okay, so let's actually jump to your group. Okay, so and then the other thing I want to do is I want to say is that in your group meeting, and at least periodically you can enable your video, so the people can see each other. You don't have to do that all the time, but and using avatar is sometimes it's not bad, because sometimes you don't want to show what you're doing at this moment, so you use avatar. But sometimes in the group discussion, at least you know occasionally I want you to show the videos, and so you can actually see each other. So that's just my recommendation. Um, so I think that's pretty much all I want to talk about. And yes, just please log into your link, that your group room, and so you can discuss. So I'm gonna actually post the assignment. So
Professor, when I logged into my group, it said I had to request to join. Is that something you can turn off for our groups?
I think I probably add each, right now. Yeah, that's true. If you actually try to log in from your email other than the university email, it requires permission. But I can.
I am logged in under my school email. It still required me to request permission.
Oh, okay. So yeah, I can try to actually give you each of you a permission for. So I gave a permission for each group. For example, group 1 link. I can actually put all your names in the group 1 link, so you should have a permission to do everything. I created it, so that's why if you want to join, sometimes they want my permission to join. But if you want to discuss, use the same link in other time, like then sometimes you're gonna because I'm not here, so you are not gonna be able to log in. That's not bad. That's not good. I'll fix that one. So today I can actually give you all the permissions to do so, but but I try to fix that one. So yeah.
Well, we can just use this for today, and then I can make a different meeting for whatever day we decide to meet this week.
For your own meeting, so you can schedule other time. You can create your own Google Meet link. Then you can just do it. You don't have to use mine. So, but during the class, if I want to meet, sometimes I can just jump back and forth between these virtual rooms. So that's why I want you to use the link. But off the line, so if it's other than class time, you can create your own link. You can pretty much create your own way to communicate. So that's okay. Yeah, that's a good idea. But I will give you everyone the permission to log into your virtual room that I created. So I will do that after the class. Okay, so yeah, you can discuss the chapter 4. I'm gonna post this assignment on the Blackboard. So they're gonna be part of your final grade, because participation is very important. So I want you to participate in there. So you just need to present questions. If you have no question, that's perfect. But I hope that you should have some question. In every chapter you don't understand it, you feel like you want to ask and bring up to the classroom, then the group meeting is the way to put together all the ideas, questions, and then post on the Blackboard discussion forum. So okay, I think that's pretty much all for today. So I'll go ahead and post the assignment, the group meet discussion. Give you some kind of guide. What do you want to discuss, and what do you need to submit? Okay. But as I say, you just need to present like 3 questions, and or 3 problems or whatever. Any topics you want to discuss, and you want to bring up three of this and post it on the discussion forum. I create a thread for each module in discussion forum, so you can actually you can follow this one, create your own thread, post your questions. Okay, so that's pretty much all for today. Also, if you use the repel.it, so I think this is a very, very good tool, but it's a little bit of confusion, because it will create a main.java, but sometimes you want to create a Java file with a different name, but it's doable. But it's you can check my tutorial I just posted on the Blackboard to see how it can perform some of the. You can compile and run the code on the repels.it. Okay, so that's pretty much all. I'll see you on Friday.
You're gonna post the assignment for the groups on Blackboard. Professor.
Thank you.
Hey. Oh yeah. So what are your questions? Yes.
So we have a group assignment that we're gonna be assigned.